Hello everyone, this is Ranjita VR, studying 8th semester ECE from Sri Venkateshwara College of Engineering, Bengaluru. Today we are here to discuss the topic called prediction of chronic diseases with multi-level neural network. These were the contents: introduction, history, objectives, methodology, result, application, conclusion, reference. First we are going to discuss about introduction. Chronic diseases are also known as a non-communicable disease, which are distinguished by a long duration and slow development. Chronic diseases such as diabetes, heart disease, and hypertension are major public health challenges that affect millions of people worldwide. Machine learning techniques such as neural networks predicting chronic diseases by analyzing large amounts of data from medical records, lifestyle factors, and genetic information. Doctors needs to use data mining or machine learning tools to summarize and analyze the data content. Multi-level neural networks are a type of a neural network that can predict multiple diseases outcomes. These input variables may include demographic information, medical history, lifestyle factors, and genetic data. For chronic patients, multi-level learning method can be used to help doctors identify the types of chronic diseases. The long duration of chronic diseases and high cost of medical care have placed a huge economic burden on society and families. The major cause of chronic diseases is the use of tobacco, unhealthy food habits, and lack of physical activity. Predict multiple diseases with the help of various machine learning algorithms such as a KNN, decision forest, random forest. Next is history. In 20th century history, the notion of chronic diseases is a construct, not a natural category. Dividing diseases into acute and chronic is an old medical device. The English physician Thomas 1624 to 89 differentiated acute means disease, meaning those of which God is the author. Chronic mean those that originate in ourselves. In the 19th century, evolutionary philosopher Herbert Spencer repeatedly advised people seeking longevity to acquire a chronic diseases. Next is objectives. To demonstrate the potential clinical utility of the model by applying it to real-world patient data. To develop a multi-label neural network model that can accurately predict multiple chronic diseases simultaneously. To evaluate the performance of the model on large dataset of patient records. Next is methodology. The first action is data collection. This system collects structured and unstructured data obtained from various sources. After data collection, they are subjected to reprocessing and are splitting into cleaning and test data sets. This was the flowchart: data collection, model construction, constructed model, diseases prediction using CNN, distance calculation using KNN. First is data collection. The real life data that includes structured data such as patient basic information including demographic, living habitat, and lab test result. The unstructured data such as symptoms of the disease faced by the patients and the consultation with doctor. Pre-processing. The collected data are pre-processed for the availability of missing values in the most of structured data. Hence, it is essential to fill out the missed data or remove or modify them to enhance the quality of the data set. Once the pre-processing of the data has been completed, it is then subjected to feature extraction followed by disease prediction. Model description. The data set consists of both structured and unstructured data. The structured data comprises patient demographics and data related to the cause of or the disease such as age, gender, height, weight, and so on. Patients live in habitat, laboratory test results, and the disease that they are affected in tabular format. The unstructured data comprises patients' disease symptoms and the information about integration with, with doctors in text format. This was the neural network diagram, explanation of neural network. Input layer. The input layer consists of data related to various potential risk factors associated with chronic diseases such as age, gender, blood pressure, cholesterol level, smoking habits, physical activity, family history. Hidden layers. The hidden layers consist of multiple artificial neurons that perform complex computation on the input data to identify pattern and correlation among the different risk factors. Output layer. The output layer consists of multiple neurons, each representing a specific chronic disease that model can predict. The output values are binary, indicating the presence or absence of disease. Result. Performance comparison different multi-level learning independent test data. The experimental results of the optimal models of various multi-level learning algorithm has shown in table. From the result, the decision tree can generally achieve good classification performance. Their index of Hamming laws are better, but the indexes of ranking laws are worse. MLKNN has poor scalability and performance comparable to decision tree. AdaBoost MH cannot obtain competitive result because it is optimized objective. It is mainly the Hamming loss rather than the ranking loss. For this multi-source data set, there are many correlation between features. So the classification effect of NB method is not significant. For the transformation method, CCT's effect of classification is not improved significantly compared with BR method. Next is application. Early detection. Multi-level neural network can predict the onset of chronic diseases before they manifest clinically, allowing for early detection and treatment. Personalized treatment. Multi-level neural network can analyze multiple risk factors and provide personalized treatment recommendation based on individual's patient characteristics. Resource allocation. By predicting the risk of chronic diseases in different populations, multi-level neural networks can help allocate healthcare resources more efficiently. Public health. Multi-level neural network can be used to identify population at high risk of developing chronic diseases and provide public health intervention to prevent the onset of chronic diseases. Next is conclusion. Chronic patients tend to have a variety of complications. For patients, multi-level learning can be used to identify their complications. This data is relatively large and neural network can fit it well even if there are relevant features. The proposed method can effectively assist doctors in the diagnosis and treatment of patients with chronic diseases. The interpretability of neural network will be analyzed in order to make new discoveries and deepen the understanding of chronic disease. These were the reference. Thank you.